today is going to be an exciting and transformative experience for all of you. You all can be prepared to be swept away by the immense gravity and magnitude of the subject expert speakers, leaders, and networking opportunities. I'd like to start by thanking all our eminent speakers, distinguished delegates, and guests for joining us today. Ladies and gentlemen, without any further delay, let's start with the first session of the day, which is the Global Spatial Innovations Transforming Industries. Space technology for achieving sustainable development goals, empowering nations, explore innovative space solutions, driving sustainable development from satellite-based monitoring of agricultural practices to space-based energy harvesting, fostering progress towards SDGs and driving economic growth. Ladies and gentlemen, we already have our panelists on the stage. Let me introduce them with all of you. We have on the chair Shri Shakya ji, Senior Advisor, ITU Area Office. Welcome, sir. Our panelists, Dr. Subba Pavuluri, CMD Ananth Technologies, Mr. Moussa, Abdoulahi, CEO, ConnectSAT Aerospace. Everyone, can we have a huge round of applause for all the panelists? And last but not the least, Mr. Rajashekhar and Chief Weather Scientist, ISRO. So welcome to all of you, and I'll hand over the dais to the chair, Shri Shakya ji. Sir.
Good morning, friends. First of all, let me express my gratitude to the SIA-INDIA for organizing this wonderful talk and having the panel of highly knowledgeable experts in the domain. We all know the Sustainable Development Goals adopted by the United Nations together with the strength of 193 nations that how the world should go. To make the future better, they adopted 17 Sustainable Goals. And in itself, if anybody reads, the aim of all these goals is to have happiness on the face of everyone. Everyone have the same understanding, same kind of the livelihood, same kind of the sharing of thoughts, availability of resources, non-divisibility, and that way if you read out the list of, I think, all 17, then it gives us a feeling that once these 17 goals, which I am just reading for reference in the memory of all of you, the first one, no poverty in the entire world. Zero hunger. We know how many people die every year due to the hunger. There may be multiple reasons, but what the goal had been set to be achieved by all of us together as humanity, that we should have the zero hunger. Similarly, good health and well-being, quality education. Then we have just a second, I think I use this play. The affordable and clean energy. We all are talking of the climate change, and this year has been the worst affected so far. The decent work and the economic growth for everyone, industry innovation and infrastructure, reduced inequalities, sustainable cities and the communities. We have climate action, life below water, life and land, peace and justice with strong institutions, and finally, partnerships for achieving these goals. Space technology is the one. Being an Indian, I think all of us are proud to reach to the moon, having the Aditya in space and now in the orbit of the sun. But we have the legends who are contributing in achieving these goals by the different ways of using the technologies in the innovative manner. And may I have the honor to start with Dr. Subba, that how the space industry or the space technologies are helping in achieving these sustainable development goals, empowering the nations in different fields. So we would like to share his views that out of 17, how the things are progressing and where we can do more. So may I have the request to Dr. Ananth.
So thank you, sir, for the good introduction to everyone on that. Namaskar and good morning to all of you. The sustainable growth as defined by United Nations, if we will start working on the Indian side, what we first we talk about the Roti Kapada Mountain. That is the minimum that is required for people to sustain and to grow. So the sustenance part of it, once the roti, the food that is required for everybody, and the next one is the housing, and of course the related to the things around that. In this regard, if you look at the way the Indian space program has grew over a period of time, first we started establishing our own satellite systems in the country, which are known as IRS systems, the Indian remote sensing satellite systems. Their objective of the systems are to create information systems in such a way that you get into NNRMS, that is National Natural Resources Management System. But again, much before the system, the indices that have been evolved by the United Nations, India thought about that much ahead of that. And we created that kind of a system, including the advanced technologies, to have the sustainable life in India. So therefore, when we received our independence in 1947, then there was also a lot of hunger in the country in the sense that there was important food grains from outside. So what the country did was basically the government provided the water and provided other the sustainable systems to the farmers, and we started growing the food crops. Now, the later part of it is now how much crop is going to be grown and what are the various economic parameters that enables the sustainable growth of food crops in this country. In order to evaluate that part of it, we have parallelly started working on an IRS system, Indian remote sensing satellite systems in the country. So, if we look at the first satellite system that has been built, which is giving the information to us on the soil, water, environment related to the land use, land cover, and not all the information coming on that. All this information was used to rotate in order to get the information on the agriculture related information. So that's how the Indian systems have evolved over a period of time. Subsequently, of course, the resolution of the satellites have increased. Then the multispectrals come up into that, and the multispectral also there was a more resolution created in that part. And then the sustainable systems, which is getting into the feeding into NNRMS. That's what the headquartered ISRO, and that is how the systems are being built for a period of time. Today, India not only has self-sustenance in these areas, but also they able to provide the technology related to the spatial data, both in terms of analytics and also the satellite building part of it, to the other countries in the world. That's why I think we hear from other countries also how they can support let's say, the Indian systems can support the African systems, or the other Southeast Asian countries also in that part of it. Thank you, sir. Keep on.
Thank you, Dr. Subba. Now, may I request Mr. Rajashekhar to add his inputs that how these space technologies are helping out of 17 these, which are these basic fields where the contributions would be more, and what efforts are being taken within the nation or globally.
Yeah, first of all, thanks for organizing this. As continuation to Subba sir and moderator remarks, so out of 17 SDG goals, so 12 goals are being achieving with the space technology and its leveraging of space technology and its applications. So if you see now the major what they listed out, so basic part what we are seeing the last decade, the climate change. The climate change impact is on all these sectors, whatever the 17 SDGs, we have the direct, 90% direct impact of the climate change. So, basically the satellites, Earth observation satellites, are giving huge information and intelligence, Earth intelligence getting from the satellites are directly being used to monitor the climate change and its impacts. So if you see the direct impacts of the extreme weather conditions are increasing, the similar like what we are seeing the drought conditions, severe heat wave conditions, what we are seeing experiencing North India last 1 month. So continuous heat waves. So which causes the large impact on the humans and production or agricultural aspects, all these things. But these things we able to predict early or be able to monitor the ground level what is the things are happening and what is the implications. So the satellites what we are having the Earth observation satellite majorly is a constellation basis is growing their constellation observations. As Subba sir told, optical and we got to multispectral. Now the era is started for the hyperspectral and synthetic aperture radar constellations are going to give the monitoring of whatever we are looking of the SDGs. So like agriculture, industrial operations, and the climate impacts, disasters monitoring, all very frequently be able to monitor. And whatever the private partnerships are coming in the constellation making satellites, the data is be able to task within 3 hours to 6 hours. We can get the data very quickly. So the agriculture, if you take the agricultural practice monitoring of the crop health and the drought conditions, water availability and the temperatures of the land use, land coverage temperatures, which gives the more information for precise agriculture and its practices. So whatever thing now we are in the technology, we have the very good hyperspectral, multispectral data, synthetic aperture and observations, which are highly getting useful for sustainable developments. Most of the out of 17 12 we are using it now. Thank you.
Thank you, Rajashekhar. In the next, I would like to request Mr. Ben, who can have the global perspective and how his company is contributing towards achieving the SDGs.
Thank you again for having me in this vibrant Indian space ecosystem. We have two wonderful gifts from the space tech to solve the SDG challenges. They can mention connectivity and Earth observation data. When you taking the connectivity, you can solve half of the challenges from the SDG list. As you may know, we use connectivity to tackle telemedicine issues, smart farming, education. So it's unlimited applications, which directly positively impact population around the globe. And although we know that more than 4 billion people in this planet are disconnected. So they have no option to get connected. And when I take the Earth observation data, I can also mention the data we can have, the data the political leader also can use to make a plan for development for their nations also. So it's a very impactful using space tech to tackle this issue in line with the SDG. Thank you.
Thank you, Mr. Ben. In fact, in India, there is a very known proverb. If something you want to learn, the people say, hey, it's so easy, it's not rocket science, right? But what we are talking today is the space technology. So it gives a perception that primarily it's very high costing. Expenditure is going to be millions. And rocket science is highly complex, most difficult. So having the experience, I think I will start with Dr. Rao again. That can you tell us what are the opportunities and is the space technology really so complex, so difficult that there is no scope for the startups, youngsters, individuals to come in, or it has the opportunities in abundance which could be utilized and then it can help in achieving the sustainable development goals and it can really empower the nations. Over to Dr. Rao.
Thank you, sir. Basically, we look at the satellite technology only as a tool in order to provide a solution easily and faster. And since you use the word rocket science, there is no doubt that rocket science was a complicated field, but today, even the school children start working on the rockets, on the satellites. So today, that is a reachable, which was not reachable earlier, today is reachable in many ways. That's why we see a lot of many startup companies coming out on that. And in fact, where somebody is seen sitting here, and in fact, she's putting things together in the satellite, making part of it, putting the girl students together into that, hundreds of them on that. So therefore, today, what is complicated technology become kind of a child's play or something like that. Now, when come to the uses of this technology, there are many already achieved in this country, but towards the sustainable growth. I will give you a few examples of some of the mission programs that the Indian Space Program undertook earlier. In fact, you can go back and into the history and then explain to you how the Indian Space Program evolved. What is the rocket science? That is the building of the SLV, then PSLV, GSLV, then ISRO. At the same time, these rockets are carried as satellites. So the satellites could be the communication satellites, the operation satellites. So building of the satellites will be in parallel. Then inflation of those satellites to the ground. So that's why the entire sustainability of the space program has been built within as a core area within the Indian Space Program in this country. Now, objective of the entire thing is towards the sustainable growth of the country in that. So that's why we started evaluating the programs like IMSD, Integrated Mission for Sustainable Development. What it means was that how to make a sustainable development in the country using the space technology. That means basically all the spatial data can be made use of using analytics how to make use of the development of the country. The another program was related to the groundwater exploration. The entire country, the groundwater exploration model was taken up using the satellite data. Then the third one is about the forest monitoring program. We will also start. That is, forests are very important for sustainable growth. To see what is happening in the forest and what further can be done, how to grow more forests in this country. So the growth-oriented part of it, like this, very many other programs on that. Then urban-related programs are very many. In order to not only get the tax collection, but also to make a sustainable growth of the urban areas in that. Then on the rural development, this is one side. Again, for sustainable development, we need last mile connectivity in terms of communication. So we started doing these satellites for the inside series of satellites for the communication in this country. And this is that's why now, in fact, we can bring out this type of solutions to the rest of the world. Already we worked out, we created the solutions for this in this area. We can bring to the rest of the world. That's why, in fact, my friend from Mr. Penn from African background, and we can always bring in the Indian technology and for sustainable growth. From the Indian way of doing things easily, and also we can create the capability in the universities, in the students, in the government part of it, is from Indian experience on that. So that's why I'm sure that sustainable growth can happen all over the globe using Indian experience, which already we built in this country.
Thank you. Not only the rocket wherein the space technologies are involved. That is one field. These are not only the satellites where the industry is working there on, but there are the specific domain where the technologies in terms of providing the data is utilized. So satellite is working as providing the information, like Dr. Rao has added that we work with the missions to provide the remote sensing information, the geo information, right? So, and he has given the example of the forest fires and all. So, in line of this, let me go to Mr. Ben. How this data is being utilized in the African region to make the things easier, and what are the specific things or the sectors wherein the achievements are there which could be replicated by the rest of the world.
Sure. So yeah, I can go with from the ConnectSAT experience, we are working on the very specific solution. So yeah, from ConnectSAT starts making movable ground stations. So we had a very nice collaboration with UNICEF using our mobile ground station to connect to some hospitals in some villages around Africa and some school also. And recently we jumped on making satellites. We are expecting to have our first launch this year with our partner Shri. So specifically, we designed a SpeedSat connecting fishermen boats because this community faces a lot of challenges. They can mention illegal fishing roughly on the Rajashekhar website. They highlight the value of illegal fishing is $23 billion in the world economy. Only East Asia is $6 billion. Yeah. So this is a very specific solution helping nation to deal with illegal fishing and also to avoid loss of fishermen in the middle of nowhere, in the middle of the oceans. And it will be very impactful also in the African region and also probably in other regions where we can replicate the same system.
Thank you, Mr. Ben, for sharing your information. Now may I request Mr. Rajashekhar to add on the same question that what are the specific areas or the sectors wherein we have experience which could be taken globally and the entire world can be benefited with those experiences. Please.
Yeah, so the perspective what we see in not only Indian region, so the globally the space technology or the satellite image data, the utilization has been enhanced drastically in the last 5 years. And if you see last 2-3 years where the translation of satellite is coming globally commercially. So where we can, I can give an experience. So if you want to monitor the oil spill in the sea, because of ship it is dredging time or because of refinery it is accident or in the two ships coalition has happened in Singapore 15th or 14th of June. So previously we have this synthetic aperture radar able to detect the oil spills and the orbit is every 10 to 15 days it will count. So like Sentinel, what we have ERS1 and ERS2 is Sentinel. So the data will take in 10 days. But this is the case in Singapore. Within 3 hours, they provide Umbra, whatever the Capella, ISRO, these are the constellation of satellites. Within 3 hours, we get in a hand of your data. But in future, I am telling this is same thing. 3 hours, we can get without involving any ground station. The edge computing going to take the AI-based edge computing on board processing. It will detect the object. You need not touch any data. You will get the solution with your mobile. To whom you are interested, to whom, what they are subscribing, they will get the mobile of the message or whatever the format you want. So the way of this technology and the applications are growing, and you can see in next 5 years. So it will come to solutions. It will come to your mobile. So if you see 15 years back, so nobody knows how to process the satellite data, satellite image. As I am doing the PhD 15 years back. So the synthetic aperture radar data we used to buy from the Europe, and we use cost even more than 1 lakh that is the time, and we don't know what are the tools to use. Only 1 or 2 tools we have to process the data. Now most of the space agencies, like if you see our NOAA or European agencies or the NASA, we have the number of tools. Anybody, any student level, they are able to process the data, able to get the free data and make the solutions. So like that, we have so many success stories in Indian region, like potential fishing zones using the optical color monitor data from OceanSat, series of OceanSat data. It is directly useful for the fisher community where fish is going to be there. So potential fishing zones we are able to get from the ocean data. This is a practical successful story which is other countries are adopting. So OCM is one of the best solution we are giving. Even Japan, other countries used to buy our data. So these are so many success stories in India, and if you look at the space technology globally, so many private organizations, private players are coming for data analysis, data analytics, and giving the applications, and it very much less cost and coming to your required analytic solutions. So that is the growth what you see now.
Thank you, Dr. Rajashekhar. Just a leading question from Shri. As an individual, how he can approach to get such data? Suppose, like you shared, that there's a lot of data and with the comparison or just having the data analytics or the data scientist kind of the activities, using the IML kind of the technologies, probably the students can develop very powerful tools or very powerful applications. But the very fundamental questions, like any individual student comes, where from he can get the data and what is the process to get the data, if he can do some light on this within country and probably even from the other satellite constellations.
Yeah, so I start from India. So we have the open data policy in space data. So where the ISRO is providing the data sets through NRSC, the portal O1 and other, we have the other portals. So with slight latency data, and it is open to anyone, and we have the terms and conditions very, very minimal. So students are using already, some engineering colleges, some postgraduate, some universities already using this data. And if you want to extend the resolutions and all, the cost of the data is very, very less for academic users. And going for globally we have very good resources available now. So where Copernicus platform, so open Sentinel forums, so we have the all type of data sets, starting from the optical, multispectral, hyperspectral, and the synthetic aperture radar observations, but not as you can use as a commercial requirements because it's not a constellation of data. So latency or the revisit will be little different. So, but if you see last 15 years, the drastic availability of the data availability for the academics as well as research purposes are huge, and NASA at the data resources open whatever the browser we can get the data From the Sentinel, Copernicus platforms, we get the data. From Indian perspective, we have the Over and other platforms, we can get the data with little latency. So there is a use opportunity for students, especially to develop the analytics, using of AI analytics and using of local other data sets, fusioning of other data sets, making the solutions. And already some students, we are seeing the publications and other forums, international national congress, they are presenting very good results using of this open source data, especially from India.
Thank you, Dr. Rajashekhar. Let me move to my friend again, Dr. Ben. Mr. Ben, are you able to add what has been spoken by Mr. Rajashekhar in respect of the African students? Suppose they want to use the data, how that kind of information is available, and how much interactive and useful it is in terms of
To be in line with the SDG, I remember you showed me that's the last point of the SDG was collaborations. So what we did is Dr. Subba, we are preparing to sign an MOU to train more than 40 African students the geospatial data analytics. So it should be very important preparing the African generation to get hands-on on those space techs and discovering also what they can handle, what they can achieve using space data in day-to-day life to solve problems related to, as I mentioned at the beginning, development plans and impacting economy. Yes. So this is the ConnectSAT project with Ananth in India to train the student from Africa. Yes.
Thank you, Mr. Ben. So let me go further to the leading question to Dr. Ram. So what we have shared that yes, we have the technology, we have the data available, right? And I'm sure you all are very technical people, very innovative guys sitting here. You are the most fruitful brains which the country has. But I would like to have the information from Dr. Subba. If somebody wants to start startups, he wants to come out with innovative ideas, what are the, say, things available in the ecosystem in terms of financial support, in terms of the mentoring support, in terms of, say, the partnership as indicated in the SDGs, if he can do some lights on this.
I think before getting into this, with the chair's permission, I would like to, we have Radha Devi has not experienced this in we have also with these, and we have seen that you have been leading the satellites also on that. You can also involve them into discussion that we get with them. And so one question that answered that on the numerical systems, sustainability, and the support system for that. I must say, in India, it is very, very poor. That has to be created. We are yet to learn many lessons from the counterparts that parts of the USA. But in India, some of the mentality of the government from the very beginning has been that, looking everything from the audit point of view, which means a rupee is more important for them. See, the failure is seen as a failure, but failure is not seen as a success for this or something else tomorrow. For example, in Chandrayaan program, we had a problem. Doesn't mean that we lost the program, but we learned from that and move on to the next program, and that program becomes successful on that. So nobody can walk properly without falling down on that. Falling down is not a failure. So the kind of system that still we have to evolve this country. And our governments are also more inclined to give the freebies to the people in thousands of millions of dollars for that than give 1 million to somebody to develop innovative things in this country. So that's unfortunate thing that we're trying to change the mentality slowly. So hopefully things will happen first. Maybe.
May I ask Ms. Radha to add up?
I totally agree with what Subba was telling. It is true from the audit point of view, and because it was total system, ISRO was having from the launch, from the design, from the payload, from the sensor, processing and marketing, everything. But now, as all of you are aware, ISRO have opened the doors and we are enabling the all type of industries and everything, and collaborations are also happening. And more, I think that is becoming very successfully also it's happening now today for the last 2-3 years. Definitely the transition will take some time, there is no doubt about it. But more on edge computing and onboard data processing, these areas, because as all of you are aware, now I am seeing in the industry one trend mostly is launching of the rocket or satellite. Till that only. After that, once the data comes, the processing methodologies, and because data is like a crude oil. Until and unless it is refined, we cannot really use it. For example, see, lately challenging because we cannot afford to have a big detector array on board with which, because we need a minimum swath of some 10 kilometers or 5 kilometers to cover an area. Even if it is a microsat or launch on demand satellite or whatever, minimum some 5 kilometer, 10 kilometer area should be covered. So the technology to use that sort of detector arrays, even in the 40% of it will be cloudy. So we don't have to downlink all unwanted data. We can process it on board itself. We should see whichever is cloud-free data. That alone can be processed. We can make an information product, and that product itself, which will be in KBs, can be readily downlinked. That should be to whoever wants. Like Capella, there are some satellites which are doing right now. That should be the future and challenging things which we should be addressing is my feeling. Thank you.
Thank you, Mr. Radha. May I request, sorry, Mr. Raju, would you like to add? And before Mr. Raju starts, one thing I want to just confirm from the industry friends. Yes, in the government people work for every penny, there's no doubt. We have the we have CBC, we have CBI, we have the CAG. That environment is there, I think we do not deny. But they are to take care of the contributors. So taxpayers' money it is. But like failure shall not be taken as a failure. I think we saw on the TV after the first our Chandrayaan 1 program, where we all were expecting that now everything has gone nicely, and unfortunately at the last moment, say, we had some tickly issue and it could not land safely. After seeing, say, the hugging of the Honorable Prime Minister with the ISRO chief, has it not given a confidence to the average scientist and everyone working that nothing to worry about the failures, let us work ahead, learn from this failure and make the thing successful. And we were all lucky that we had the second thing, highly successful launching. So with that, I'll come back in terms of challenges, but over to you.
Yeah, thank you, sir, for giving me the opportunity. I am here in Raju working as Secretary to the Government of Assam. Earlier I was there at I know what are main thing is the lot of developments are taking place. I know Subba sir since my starting career in ISRO. I was there. project student working there. So now we reached a stage where space technology provides a lot of opportunities in terms of availability of many satellites as well as the satellite communication. So as far as the users concerned, particularly I work in Assam, the floods is a regular phenomena every year. And then now last 1 week, 10 days, heavy rains, almost 3 lakhs to 4 lakh people are affected with the floods. The main problem, like Rajashekhar mentioned, that cloud is the main concern. And getting the data in a real time is a big issue there. So that means, as she said, on-board processing, and then telling that exactly how much of the area is getting inundated. And another important requirement is because once it is flooded area, how much extent it is flooded. But at the same time, using the GIS, we will also know that which are all the habitat settlements and the how much of people are affected. And also, we should also have the high resolution digital elevation model, so that we know that how much depth of the water is there and how much time it takes this thing, and providing the relief. So that means in near real time the requirement, the challenge is to provide the relief. How quickly we can provide, and how high resolution is. So that's why availability of these satellites and getting the information. Another revolutionary things happening is IoT sensors and availability of these IoT sensors and doing the precision farming. So it is advantageous because we know each feed-wise inventory of the soil and soil nutrients, NPK, all this, how much is this thing, which are the areas it is deficient, so that we can attack only those areas instead of going for the whole area. So this is one more area. It is extensively Government of India is also promoting under the digital agriculture, agriculture survey. So there another challenge is digitizing the whole cadastral level of individual farmer registration to, and also accurately to the georeference to those things. So it's very important. It is going on, but at the same time, availability of the satellite data is more multispectral and hyperspectral. So it will also help us to know the actual health of the condition. And then another thing is how related to the insurance sector. See, there are two sides. One is the government and individual farmer side, and they insure this thing. Other side, insurance companies both claiming and counter claiming. So that means the satellite data is really going to help giving the actual status and then also providing the remuneration what has to be due for the farmer. So these are all the things, and then it is going very right direction. I think SIA, India, what is doing a great job in providing the opportunities and then expanding the activities and then making India. So we are also trying to become a developed country in 2047 as the Prime Minister's ambition. And then satellite sector, I hope will be also become #1 and also serving the country and as well as the whole world. Looking great. I'm sure that we are going to do good service for the country.
Thank you, Doctor. May I request Ms. Vimati?
Good morning, everybody. Thank you so much for giving me this opportunity. Indeed, there are huge number of challenges, if I have to say. Roti Kapda Makan is the perfect term for us Indians to start with, because that is where the college loans. So students are not able to think beyond, out of the box to do something. So the startup culture is fantastic, but I think it is a long way to go. I run this organization called Space Kids India. My motto is to catch children young, and predominantly the girls, because girls in STEM are only still 14% and way behind. So I want to bring them to the main forum. And here it is not only skill development. Immediately people say the government wants to invest money in skill development. any CSR fund, skill development. So everybody cannot be following the same path. You need doctors, you need engineers, you need accountants, you need everybody. So in this industry, when we go in for requesting funds, people say, no, they can do tuitions, we will do admissions, we will give them fees. The ultimate CSR goal will be only to provide food or school fees. We want to go beyond that. And that is where, it is not prima facie to appreciate Dr. Subba, but once I had presented what we are doing with regards to girls for the Azadi SAT, wherein 750 Indian rural girls from Kashmir to Kanyakumari, we handpicked them, gave them the training to how to build a satellite. It's payload. It's not huge science. A high school student cannot do a telescope. She can do a small accelerometer, gyroscope. She can do that. But that's the first step into satellite building. So we did that, and all our testing, he supported with his Ananth technologies, and because every testing is at least about 2 lakhs, 3 lakhs, and for us it is too much. So that was a great support, and it is a request to the government that, of course, Nukur is here, she would agree that NASA, that is where our first challenge we won. We built the world's lightest and first ever 3D printed satellite, the ConnectSAT, and launched through NASA's Stereo suborbital rocket from Wallace, Virginia. That is where the world took a turn and said, oh, they are doing something with children. Because otherwise, I took 6 months to convince our government to give us permission to launch a high altitude balloon in 2015. So, everything is an embargo. You need to release that embargo. You need to have faith in your younger generation that they can do something. And grace of God, we are moving ahead to do a global satellite this year called the SHAKTI-SAT, Mission SHAKTI-SAT, involving 108 countries. And it's all going to be young girls, high school girls. About 12,000 students will be benefited out of that. We're going to be creating history because we're going to be launching into lunar orbit. So we need all your support. And Dr. Subba, thank you so much for this. Thank you. So we need to go a long way, but we are there. Thank you.
Thank you for your celebration and congratulations for the accomplishments, what you have done so far. And you really justify the name Shri. That is, I don't know whether my friend man understands. Shri, it's not only the sounding good. Shri is considered as the goddess of the wealth and the knowledge in terms of that. So she is really representing the Shri and justifying her name. I understand there are challenges before we go to the challenge round finally. I have just one aspect, that what could be the policy interventions we as an industry expect from the government. Because if we see the journey of last 2-3 years, right, in the space technology, we have got the space communication policy, we got the space policy itself, we have got the remote sensing policy. So in terms of the policy formulations, the government has come out with wonderful programs. We do have the startup arrangement, we do have the stand-up arrangement, but where are the gaps where we feel in terms of the space technology making more innovative, more effective, coming out with the better results, giving the faster, boost to the sustainable development? Can we request all the panelists to add what would be those kind of the interventions from the government?
Instead of claiming that only the panel, we have this doing that, and what I request, we have Dr. Dadwal here, who is a part of our National Institute of Advanced Studies, and who is also director of the National University Agency, and also has academic experience of working with, in ISRO, one of the centers in India. So, since we're talking about sustainable growth, sustainable goals that have been set by the United Nations, and what the space technology can do in terms of achieving that. And his new question is about what are the gaps that where the government has to do something on that. in perhaps, but the work can flow more like it is this time.
Good morning. Thank you, Dr. Subba. I think since you are nearing end of your program and the topic of sustainable development is really very large number of goals, plus the entire humanity has to be covered for food, water, education, safety of women, housing, right, and sustainability from climate change. But I would only say the real challenge is satellites can be used provided we consider satellite as a public good infrastructure. If there are two entirely different streams. Weather data is all free. Anybody can use it. You can use the forecast and do so many things. High resolution data is costed. Somebody has to pay for industry, etc. There is a middle ground of medium to coarser resolution, continuously free available data, so that all communities, all stakeholders, for their purpose as well as regional thing, they use it for sustainable development. Hundreds of ways, from urban to groundwater to forest to water, everything. The second important policy, what is required is, which happened slightly in the, that we have opened the data, but we do not have really huge open data sets. Like, can we really have the entire census digitally, reference spatial data set to reach out to any community? No. Do we really have the forest cover digitally accessible? No. So like this, I can maybe list down dozens or more such things. So we need to have this open data policy. So people think Google is open. Google is not open. Beyond a certain use, you have to pay for it. The only open thing is Open Series Map. So I think we need to embrace openness in geospatial. Thank you. Thank you.
Yeah. Somebody would like to add further from the audience on this?
We have Mr. Page, who represents the Brahma, interesting thing, perhaps you can contribute something on this.
Thank you, Dr. Subba, for this opportunity. I think various dimensions, and I'll just talk about what we are trying to do, or we are attempting to do in a slightly more semi-governmental setup, right, to democratize space and space access and actually taking it a bit more to the academic level. So what we are proposing to do is work with the Maharashtra government state university to establish a space research program, and for that we have kindly requested the industry help of Dr. Subba and SIA. The objective here is to help build a larger academic industry interface, help students get into the understand the broader context of space industry and research and the various elements to it. And I think as we go along, that will also help to build a larger ecosystem to support the forecasted growth of the space industry in India, which is probably expected to grow about 5 times from where we are over the next decade. So I think that would be, and obviously public good, as the speaker before me spoke, right? One of the key outcomes of this initiative would be a lot of data information which will be generated and then be made available through academic format or through a framework for larger public good, be it on the citizens or be it on the community side or even the local government bodies as well as the state government. So yeah, that's about it. Thank you for this opportunity.
Thank you. Mr. Rajashekhar, you would want to add anything as requirement of the intervention from the government?
Yeah, so as the girls are told, the data policy is open now. And you can see what are the available data sets are coming out from the agency. And the coming to the private partnerships, so we can see so many private startups are coming up, and the growing of the startups and the supporting to the startups is not like what Subba sir told, not like West. So where they having more funds and VC fundings are huge, but it is growing in India. So as speaker is telling, maybe next 5 years we can see the large growth in the policy side is open now. So many collaborations will come, international collaborations are going to come. So the technology will develop, and as well as the data and the openness of the data and the reduction in the data, cost reduction in the data sets are going to come down there.
Thank you. Mr. Van, you want to add anything in terms of globally policy interventions are required? Because even at IT level, something is going to be done. We are going to have the World Telecom Standardization Assembly in the October. So probably that can also be taken as an input to the world community.
Well, I can share from my personal experience. Convincing political leader from the developing nation to invest in space tech was a long run. So you may have some answers like when you start talking about space for good, investors say, oh, this is for no profit, maybe I will not get my money back. So this is one thing. The second thing is, some decision makers could say, why are you going to space? I have a problem now on Earth. So we had different approach, but I think what worked is the advocacy, teaching them that we can solve a problem we face on Earth from the space. And it worked now. Developing nations are investing in space tech. We have a vibrant startup ecosystem in Africa right now, and some launch already made. And we are open for collaboration. This is what we are doing right now with India and other nations globally. Thank you.
So I think with the permission of all my panelists here, may I go back to the audience here. If you have any questions, kindly raise your hands and let us have the conversations more closely. So any question on the discussion so far, or you have anything relating to satellite and SDG? Yeah, include, Dr. Lakshman is there from the academic. Yeah. Please give it.
Yeah, I am Professor Lakshman, leading the research and training unit for navigation and electronics university. So generally in the academics, what we are observing is most of the times when they are entering the academic institution, they are having a lot of ambitions. But by the time they are reaching the final year, they are looking only for a job and how much pay we will get actually. And they are more towards that side instead of trying to address some problem. Unless they are getting the inspiration or motivation, yes, I have to solve this problem, then only they can address the problem and also they can start contributing to the nation or society or technology also generally. That is the first thing what we are observing is in the academic institutions. Because at our university itself actually, there are almost 4 to 5 departments in this area actually. For example, there is one department called geochemistry, geophysics, geography, geoinformatics. Of course, also a research center in the navigation electronics. We are trying to combine all of them together to address some problem like that actually. Yes, what we can do in the geoinformation systems or something. but people are having some other ambitions generally when they are entering. So somewhere we have to address that problem also in the society. Yes, for that purpose, of course, we are conducting hackathons and other things actually. But by the time they are reaching the final year, they are forgetting to address this problem, whatever they have earlier tried to solve the problem. Once they have completed or graduated from that, they are not all looking into that problem. Actually. That side, somewhere you have to do something. The geo-information systems also, because many people are working in the colleges also, universities also. But how to make that sustainability of that interest is also one more part what I am thinking in the academics. That's how to catch them by the industry or other people is also one more important point I am thinking in this discussion.
Thank you, Dr. Expert. Any questions so far? Please. Can you introduce yourself?
Thank you for the discussion. I am Abdoulahi from Indian Council of World Affairs. My question is on how much is the data that we collect is prone to manipulation, and what do we, how do we ensure the security and privacy of the data that's there for research? So that we can get a true picture of how the sustainable development goals are going to be achieved and avoid manipulation.
She connected with two different things. One is the security and another one the sustainability. I think you will she can give a perspective on the security point of view because it gives you security day in and day out.
So now high resolution data or even the strategy sector is easy. Everything is through encryption. Data will flow through encryption, in-house developed encryption methodologies only. And other scenario like as we were discussing, Moussa resolution data and all is anyway free. You were mentioning about in the which domain security of the data, high resolution data exchange.
When you say any sort of data in space, like I hope it doesn't lead to weaponization of space.
Yeah, weaponization, militarization part, fine. Once the weaponization, when we talk about it, yes, it is required. At least for a deterrence, we should be ready for all such like anti-satellite attacks or whatever. At least for deterrence, we should be ready. If not for other things. Because it is very important to the space as such should be protected. More and more things are going on the space, and space itself is a battlefield now. So it is very important to protect the space. That there is no doubt about it. So I think different space agencies, sort of organizations are really working towards that weaponization part of it. But here in this forum, I have one suggestion, like a sort of standardization of data across different agencies, whether it is really happening or not, whether government can do something towards that, at least a base data or something if it is available. Because now, even though, like suppose a map, making a map, Survey of India is the authorized agency for map, but for small scale or large scale applications, so many different types of maps and all getting generated, and so much of data duplication is also happening, even within the government organizations also, because of the lack of all work in silos sort of thing. So whether any sort of standardization will help, or if from the government side, if any base data is made available, so that whoever is making will be a stack of it. I think I am not very sure how data standard base layer or base maps and all are freely available for anybody is my feeling. If it is, it should be like that, so that there will be an interoperability and the data sharing will be more easy. Now, if you see the targets, I am talking from the strategic point of view. Suppose you take a target location, whatever target location identified like a coordinate, latitude, longitude, whatever we say, that itself vary across different agencies likely, because it need a base map or something over which it has to be tagged, geotagged, and so this is one I feel there should be a standardization within from the government side, which will be helping all industries or whoever is making, because basically after the launch of satellite, data should come. It is going to be a data deluge in future. That is what I feel, because small satellites launch on demand, so many satellites are going to be launched, and how the data will be effectively utilized even across the domains is one thing which we have to discuss. Is my
Thank you. I think just to reply the first part, how the government takes care of the data, privacy per se, so it doesn't get into the wrong hands. So I think for our audience, I have been the Chief Information Security Officer for the telecom sector, entire on behalf of the government of India. And I think that is where the large of data gets generated similar to what we get generated in the satellite. So as a policy, we have two aspects. What is sensitive data, what is non-sensitive data, right? So when we call up the open data policy, only the non-sensitive data is made available. The sensitive data is not provided. So that is one layer. And second, I think Ms. Radha has very nicely given that you have to have the exchange of the data only after having the due encryption provided there. So that takes care. So globally, I think everybody knows the sensitivity of this data, and there are mechanisms that what is allowed to be there in the public and what is not to be allowed to be there. And I think that is a thin line here to make that how much is to be made available and what is not to be made available. This will keep on going. Now with this, may I request the question, I think my friend from the front class. We have 4 minutes more, so let us have the question fast.
Myself, Manoj Patil from MIT University, Haryana. I'm professor here in the department. I have a question from Mr. Rajashekhar. Our students are working on the technology for making AML and other techniques. Is there any community for helping them, like if they are getting some problem, like using the satellite data or analyzing those data? Is there any community for helping those students?
Yeah, the community, okay, I will tell global, not in India. So community based, what we can have, there is a tool, the Nest tool, ISA is giving. So where the open source data or whatever the data is available. So for that software, for that tool, there will be a community. So we can discuss what are the issues are coming, and further development they have who can get, and the NASA community they have. So we can communicate and the discussions, what are the analysis, what are the errors, what are the solutions are coming up with this data, and beyond the using of this data to using AI ML, what are the final solutions is coming. There is a community survey. And with respect to what data are you using and what platform you are using.
Thank you.
Next question, please. My friend from that.
Hello, I'm Dhruv. I actually wanted to talk about the future of propulsion when we're talking about sustainability. We produce a lot of carbon emissions. So, like in Shakya and Shri, only a last stage is using oxygen. So that's sustaining. So will we use nuclear propulsion and sodium? What is the future in propulsion to reduce these carbon emissions?
Thank you.
Dr. Rao and Rajashekhar. Expert in the area of propulsion side.
I think we have to reflect, right? That's the advantage of having the Shri.
No, children, so there's one startup called Abdoulahi who is doing green propulsion. They're working on it. They've already tested one. So I think you should connect with them, and they are supporting other college students also to come up with that research.
So I think since we are reaching almost to the end of this time, I have one question to the panelists, maybe primarily because I have attended work in the communication for almost over 36 years. Nowadays there is always a news in papers you will find that the spectrum is going to the from what the satellite used to have in the mid-band, what we used to have in the millimeter band, is going to the IMT, the International Telecom Mobile Operations. Then we think that there is going to be auction of the spectrum, this and that. There is also talk that the services which are being rendered by the IMT operators or by the mobile operators like the broadband or the say IPTV and all, this all will be made available on the lower orbit satellites. So, from the experts on the dice and off the dice, I have a very clear question. How do we perceive in terms of the sustainability of the technologies? Are IMT and satellite technologies are going to be competitive and complementary, or they are going to eliminate one another? Please. Can we start? Okay.
Yeah, I think this is a complementary solutions. More and more we are talking about space and terrestrial infrastructure. Integrated space and terrestrial infrastructure. Yes, in ConnectSAT, always to be in line with the sustainability. We use what we call in the industry white space. Yeah, so when our ground station catches the town, we use the white space to diffuse the internet. When with the classical TV antenna, you can connect it with the internet. So I think this is a very complementary solutions, and we use what already exists to invent something more.
Thank you. Great lecture, Dr. Rajashekhar.
Yeah, there is as meteorological perspectives, so ground-based as well as satellite-based, the downlinking of the data and the operations of the remote sensing observations. So definitely there is a future. There will be the conflicts or the interference about the frequencies, but there is a spectrum of frequencies has been identified already. But in future there will be a demand of the communication operated spectra. So definitely it is going to be slight frictions among the observations with other sectors. I hope that will be solved.
So I think since time is over what was allocated to us, can I just summarize?
To your words, your words, very important question. So we are heading toward integration. Yesterday we had two sections that had feasibility, feasibility, we talked about. It is only the talk that's going on, this discussion is going on at the IT level. That what will be the future department of spectrum, the common airbase for both. I keep on advocating that fact. So as there will be integration, common airbase will be there, but ground would be that complementary to services, and complementary to services. So you cannot draw a line. So I think this is going to be very exciting. So for the spectrum allocation, I think this telecom will have set aside that kind of population, situation will go for option. They have to decide on the electricity. Thank you very much.
Thank you. So let me thank all the panelists for their very valuable inputs. In a summary, what I can see to share with all of you. Space technology even which can be used for almost all 17 goals what are defined by the United Nations. We have huge opportunities. Yeah, that is yet to get this thing. And huge opportunities in terms of not working for the rocket, the satellites, but the applications wherein without much of expenditure people can start contributing, and larger the application you get involved, the probability of accomplishing the goals in terms of, say, poverty eradication, or in terms of the better education, better climate, all is possible. There are very, I think, progressive policies available in the country. Globally also we may try for the same, taking India as the platform, and the associations like the CSAT to take forward. And we will request the CSAT management to forward the recommendations based on the discussion, what the policy interventions that come out from here. That is probably the satellites public infrastructure should be considered as what we call the DPG, the digital public good, or the like. So once it is a public good, the availability of the information is good. Similarly, I think one more good input had come, that although the open data policy had come out, there's a requirement to get it more leveraged and include much more information therein. And I think one of the wonderful ideas had come from ISRO, that we need to have a standardization for exchanging of data. Otherwise, something comes from A, something comes from the B. So it's very difficult to coordinate. And I'm happy that a lot of academicians are there who are working in this field. Future is very bright. I'm sure it is not the sustainability what has been defined as the goals is going to be there, but the whole segment is going to be highly sustainable. Please use your innovative ideas and let us work together to make the world better, achieve all the sustainable goals, and bring the happiness on everybody's face. With this, I think I would like to close this session. Thank you. Thanks to all the audience people.
Thank you very much. I would just like to say what an outstanding start to day 2 of India Space Congress 2024. It was such an amazing and incredible session by our esteemed panel. Thank you very much, gentlemen. I request our chair, Shakya sir, to please present a memento as a token of appreciation to our lovely panelists. Firstly, to Subba sir. Thank you very much, sir, for joining us today and sharing your expertise with us. Everyone, can you give a hand to all our panelists? To Mr. Ben Moussa, Abdoulahi, Dia, thank you very much, sir, for joining us today. And lastly, to Mr. Rajashekhar M, thank you very, very much, sir. I request Ananth sir, Director General SIA-INDIA, to please join us on the stage and present a memento to our session chair, Shakya sir. Thank you very much, sir. I request the panel to please come for a group photograph. Ladies and gentlemen, as we have the parallel sessions going on in the other halls, at 2:30 p.m. at Regal Hall, we have a startup mixer session. So I request you all to join us at 2:30 for the startup mixer session.